Okay, so to help solve for number, I guess it would be 1, 2, 3 on the series circuit worksheet number 2. All right, guys, I know it says just solve for these 3 things, but just make a table for everything. It just makes it easier. So for this, what you're going to wind up doing, if we make our table, all right, if we draw this guy out, we make our table. So roughly, this is what it looks like. So again, the symbols. This guy is an ammeter, tells you what the current is in a series circuit. Series circuit, current's the same everywhere. When you see this symbol, all right, you got a circle with a number and V in it. That's telling you the voltage drop across a certain point. So here it's telling us the voltage drop across resistor 2. When it's shown across the battery, that's the total voltage. So we only have 2 resistors, so we're gonna have 1, 2, then T, and then fill in the things that you know. You know the total voltage here. You know R1 is 10. And then you know the total current is 5. And then you know V2 because this is the voltage drop across resistor 2. So this right here is 25 volts. So these are the pieces of information that you know. So a couple other things. All right, let's just do this. When you have the current, once you find the current in a series circuit, it's the same everywhere. So we know this dude has got to be 5, and so does this one. Now, what else can we figure out? Well, we have 3 missing pieces, and we have 2 of the 3 variables in each of them. So, yeah, I mean, pretty much, sometimes some people wouldn't even need to, because the voltage drops across the resistors have to add up to be the total. So something plus 25 has got to equal 75, which leads you to 50, but I'm just going to show you where that number fully comes out from. So using the triangle for Ohm's law, VIR, all of them go together though in the same row. So V1 is going to equal I1 times R1. So we know that current there is 5, and the resistance value is 10 ohms. Multiply those 2 together, you're going to get 50 volts. So that's where this guy is going to come in. And it should make sense because 50 plus the 25 is going to give us our 75. And then you can do this one of 2 ways. You could have gone in, it didn't matter the order here. You could have figured out, okay, R2 because you have V2 and I2, or you can figure it out IT, or I'm sorry, RT. But let's just show it out. R2, if I cover up R in the triangle, that would be V over I. So it would be V2 divided by I2. I'm going to have 25 over 5, which is going to give me 5. And the unit for resistance is ohms. Now, again, there's 1 or 2 ways you can figure this out because total resistance is equal to all your resistors added together. So 5 and 10 is going to give me 15, right? Or if I was looking for RT, I can cover, again, R in the triangle, and it would be VT over IT. And that would be 75 over 5. Which also comes out to be 15. So either way, that works. So when they're telling you like, hey, solve for this, that, and the other thing, as per, it's like solve for just this, this, and this. Well, feel like when you have the table, or you guys make the table, everything else, it kind of just fits. I feel like it helps everything kind of like come together instead of you trying to just solve one piece of information. Doing the table at least tells you exactly what you have, and then you can figure out like, all right, do I have two of the three? Right off the rip, you only had it in two positions, which was here and here. So you could have found this guy right off the rip. And then, well, if you know what RT has to be, and you know the other resistor, you could have done 15 minus 10 and gotten 5. And then you could have said, okay, all these things are 5, and then 10 times 5 is 50, or 75 minus 25 is our 50. So there's multiple ways you can do some of these problems, all right? Gotcha. Helps. Is there any other one on that is like confusing people? Number 6.
Yeah, I'm actually really confused. I realized what I did on number 3. I divided. I multiplied instead of divide.
Okay, so for number 6, if you're looking at this, you have the total voltage is 40, V3 is 20, and V2 is 20.
Oh, all right, no.
Right?
I'm good then.
So then the total voltages have to add up and equal 40. So if you have 20 and 10,
The other one has to be 10.
that means this has to be 10. So once you find that, all right,
Yeah, all right, I got it.
you can figure out the current through this guy here, because you know the resistor value and its voltage drop. So you can find current using that piece. Current's the same everywhere.
Yeah.
And then it's like voltage divided by current gives you this resistor. And since R1 and R2 have the same voltage drop, they should wind up having the same exact resistor value. All right.